Hello everyone, welcome to my channel, The Big Boolean Theory. This video is part of a lecture series on operating systems, and currently we are on the second module of this course, that is process management. So in this module, we are trying to understand how the operating system manages the CPU by providing this abstraction of a process. So within this second module, we are currently on the second topic, that is process address space. So as I described in the previous video, what is a address space? Basically, it's a collection of addresses, right? This address space for every process in the computer system, it has a associated address space, which is called the process address space. And this defines how the memory looks like from the perspective of the process, right? And this address space is where the code and data of that particular process is organized. So we also saw in the previous video that our address space is organized into different sections, right? Like code, stack, heap, right? And data section. So all of these are different sections and each of them have a dedicated use. So starting from this video, what we are going to do, we are going to pick each section and talk about them one by one in detail. So let us start with the code section in this video and understand what does it why is it used, right? So let's understand the code section. So now let us discuss about the code section and understand it in more detail. So basically we have a process in a system, right? And as we already know, with every process, there is an associated address space. This address space is a collection of addresses, and basically this gives a view of the actual physical memory, a limited view of the actual physical memory to the process, right? So this address space is also called the virtual address space or process address space, and it gives a limited view of the actual physical memory to the process. We have already discussed about this in the previous video. So now let's talk about the organization of the address space. So as we already said that this address space contains the basically the code and data for the process, and it is organized into different sections, that is stack, heap, data, and code. So before talking about the sections, when I say this address space contains the code and data, let me clarify this statement a bit. So the code and data is present in the physical memory, right? The address space is just a collection, right? Collection of addresses. Actual code and data will be present in the memory only. It's just that this address space defines a view of that code and data in an organized fashion. In the memory, it could be there would be no organization. It's just random raw data. But this address space defines a clear organization, like this structured way to that data that is sitting in the memory. So now in this video, we are concerned with the code section. So apart from the code section, all of the data, all of the other sections are concerned with the data part of the program. So as we have already studied in the previous topic, what is a program? A program is a collection of data and instructions. When you run that program, you get a process. Now, if in that program, there are, as I said, two parts. So the instructions part go to the code section. So the code section is very simple. It contains the code, the instructions for that program, right? And the data part is organized in the other sections. We will talk about these data sections in the later videos in this topic. So in this video, let's talk about the code section. So basically, it starts with the source code. You write your basically first of all you write the source code in some high level language like C, C++, Java, or Python. And this high level language is similar to natural language like the English language. It has some syntax, but is still very at a level which the computer cannot understand, we can understand. So the first step that we take is that we compile this source code and we get the executable code. So basically, when you compile this, you not only get the code, you also get the data. So that bundle of code and data is the program, and that program consists of the executable code, which is in the binary format, that is zeros and ones. This format is also called machine code, which the machine understands. So there is the source code which we understand, then we compile it to generate machine code, which is in binary format, right? And this machine code is something that the CPU can understand and execute. So when you launch the program, right, that is when you have a process, and with that process there is an associated address space, and within that there is a section called the code section, and in the code section goes this executable code, this instructions, that is these zeros and ones. These machine instructions go to this section. So let me tell you how all of this works. Basically, it let me show through step by step. So when you compile your source code, you get a program. This program contains both your data and instructions. It's an executable file which is residing on the disk. Now when the user conveys their intention that they want to launch a program, then the user interface software conveys requests the operating system to launch the program, and that is when we will have a process. So let's say the user has launched this program. Then, as we already discussed in one of the earlier videos, this is basically we are just re-going over the journey of a program to a process, and we'll just see how the code section is created and what does it do. So when the operating system is launching this program, it is creating a process. Basically, it will load the program into the memory. In the memory, all the code and data for that process will be loaded from the disk, right? And this will be accessed via the process address space by the process, right? So from the disk, we copied all of the data and instructions into the memory. This region is in the physical memory, and now the process will access this via the process address space, right? And now this region is organized into different sections, as we already know, and within this there is the code section. So all of the instructions, the binary instructions which has to be executed, will be loaded into the code section, and the rest of the sections will have the data. So this is basically how the code section works. It will contain the instructions, and when the process is running, the CPU will be fetching the instructions from this region of memory, right? So it will start from some starting instructions, and all of the instructions in the code will be fetched from this region of the memory one by one, right? So that is how the execution of the process will be interacting with this part of the memory. So this was about the code section. And finally, as part of process creation, the other steps will also be taken, like setting up the IO devices, the CPU registers. This we have studied in the earlier video, but our main point was that in this video, this region, that is the address space, how the code section is organized and what does it contain. So guys, this was it for this video. In this video, we understood how there are different sections in the address space, right? How the code and data is organized, and how the code section contains the executable instructions for the process. So guys, this was it for this video. Thank you very much for watching, and I will see you in the next video. Thank you.